Okay, we're going to go through exit slip 3-1. And this I can statement had to deal with being able to write different fractions and decimals in different ways to get a better understanding of place value and of fraction decimal equivalencies. And there's expanded notation and all kinds of ways we'll look here at being able to read and figure out numbers. Okay, so we're going to circle the numbers on number 1 that are equivalent. All right, so when we're doing decimal place value, we have to remember the first column is the tenths, and then it's the hundredths, and the third one is the thousandths, and they always end in th. Okay, so when we're doing that, we know we're less than 1. So for example, we would read this one 34 hundredths. You always read it with what column you end with. This is the hundredths column, so you can just say 34 hundredths. I know that's 3 tenths, and I know that's 4 hundredths, and you combine it, you have 34 hundredths. Okay, so in this case, I know this is 34 hundredths. Okay, and I know that's equivalent. I'm going to go over and look at this one next. I know that's also 34 hundredths. Remember, the 0 afterward has no value. I have 0 thousandths. That's nothing. So it's still, I could take that off. That's 34 hundredths. So that is the same thing. They're equivalent. Whereas in this case, this would be 34 thousandths because I end in the thousandths column. So that would not be equivalent. That's smaller. This would be 304 thousandths. So that doesn't work. That's not 34 hundredths. I don't have a 4 in that hundredths column. And then this would be 34 ten thousandths. Very, very small. Again, that is not equivalent. The only two that are the same are 34 hundredths. Okay. Number 2, we're supposed to cross out the names that do not belong in this name collection box. Okay, so I always want to say the number here and see how much, or how to say it and the value of it. And this would be 8 and, remember there's a decimal, we say and, 32 thousandths. And 32 thousandths, so we're looking for all the things below in this box that have that same value. So here's an example of expanded form using decimals. If I do 1 times 8, that's just telling the value of the ones column. Okay, that's the ones column. 8 times is 8. This says 3 times the hundredth column. Well, when I look at my hundredth column, there is a 3 in it. So 1/100th, 3 times is 3 hundredths. And then I have 2 in the thousandths. So if I take 2 times the 1,000th column, that is what this equals. So these are all the same. So this would work. I'm not going to cross that one out. Second box, 8,032 times 1. Anything times 1 with the identity property is itself. So that still equals 8,032. Definitely not close to 8. The second one, 8,032 times 1/100th. All right, so again, if we think of, we want 1/100th of 80.32. So we know the value is going to be less than 8,032. And we should know that multiplying by 100th the same as the dividing by 100. You're going to make it 100 times smaller. All right, so if I divide this thing by 100, you could actually show the work, but if we understand this little cheat step here, every time we move the decimal once, since place values get 10 times bigger or smaller depending on which way you move, if I move it once to the left, that's like dividing by 10. Move it to the twice. It actually becomes 80.32 if I just want 1/100th of it. Okay, so that does not equal 8. So that would not be correct. The next one is 8,032 thousandths. Remember, this is a fraction bar, so it can mean 8,032 divided by 1,000. So if I want 1,000 times smaller, basically 8,000 divided by 1,000 is 8. So again, if I'm estimating, that would make sense. Or I could use the decimal here and divide by 10, 100, 1,000. Notice it becomes 8.032 or 832 thousandths. So that is the same. And if I'm going to divide by 1,000, that's not the same as dividing by 10,000. So I know this one would actually be smaller than that. It'd be 0.8032. So that would not work. So actually, there's only 2 of this and this that equal 8 and 32 thousandths. Okay, so there's the first couple of examples. I'll pause the video if you need to here and make sure we have these written. And again, we can talk about these more if you're not understanding why when we do small group things. So let's go ahead and look at the last example here now. Last example now, we're trying to add 3 names to this collection box. So we're going to actually put them in here now and write them in different ways. Remember, we're focusing a little bit on expanded form. So let's just pick a few to fill out here. I know this is the tens column, and I have one of them, so I could say 1 times the 10 column. That's 10, and I know that's worth 10, plus this is 2 times the 1 column, which equals 2. And in the decimal, we know this is the 10th column, plus we have a 6 times the 1/10 column. And again, there's the 10th, so 1/10 times 6 is 6/10. Plus I have 5 times the 100th column, because we're out in the hundredths, so 0.01 now. Got to get out to the hundredths, so this is 1/100th. 5 times is 5/100ths. So I've written it in that expanded form and done each value separately. If you add all those together, you get 12 and 65/100ths. You could also do this like a fraction, all right, which would look a lot the same. Do expanded form with fractions. So the first part would be the same. 1 times the 10 column plus 2 times the 1 column plus 6 times the 1/10 column, but let's write it as a fraction. Okay, these are both 1/10 plus 5 times the 1/100th column. Both these are equivalent. One's just in decimal form, one's in the fraction form of expanded form. Okay, we could write it like a fraction or a division problem, or we could just write it like we say it. 12 and 65/100ths, 12 and 65/100ths, and just write it as a mixed number. Okay, change that decimal to a fraction part there. 12 and 65/100ths. We could do 12 plus 65/100ths, because I know that together is 65/100ths. So all kinds of ways we can do this. We could do it as like a fraction, or which means more division. So we could do, for example, 1,265. Take the whole number and divide that by 100, because I know that moves the decimal in 2 spots and makes it 12.65. And again, I could write that different ways as well, but that's just a few to get that name collection box filled out. If you have some others that are a little bit different, we can share those out after we stop the video here. So again, make sure you get these written. You got your first exit slip answer key.